My name is Gamson Elijah, and I'm doing a presentation on albinism, a genetic disorder in our daily life. My topic, albinism. When we talk about albinism, we basically classify albinism as a congenital disorder characterized by the complete or partial absence of melanin pigment in the skin, hair, and eyes. And this is due to the absence or defect of tyrosinase enzyme involved in the production of melanin. And when we speak about albinism, it was dated back in the 17th century when a man named Balthazar Tellez, who was an explorer, came up with the name albino, which means white negro. After he saw that was after he saw an albino tribe. So that was basically how the first discovery of albinism came about, because Balthazar thought he was seeing two different races. Now, when we talk about albinism, we can also speak of it as another name called the hypopigmentation, or acromia, or achromasia, or achromatosis. And talking about albino, the name is an organism with what? With a complete absence of melanin. And note, organism. It can be an animal species. It could be human species. Yes, albinos are not only found in humans. Yeah. And an albinoid or an albinic is an organism with only a diminished amount of melanin. So we have those that have a complete absence of melanin in their system, and that they show diverse effect and very great effects of albinism. And we have those that have a very diminished amount of melanin in their on their skin that actually give them they show partial signs, some symptoms of albinism, even though they are albinic, but they don't really most of them don't really have very diverse effect, and then their life are not really their lives are not really threatened as much as people that have a complete absence of melanin in their skin. Now, when we talk about melanin, it's also called melanin is a pigment here, and it's a substance that gives the skin and hair its natural color. So basically, when you have the melanin in our system gives color to the iris of the eye, feathers, and scales. And melanin is synthesized from the amino acid tyrosine, as we all know. And in the skin, melanin is formed by cells called the melanocytes. So if the melanocyte cells are not available or they are deficient, definitely melanin cannot be formed, and therefore the conversion in the biosynthesis cannot take place, and therefore you're gonna end up with what we call albinism. And there are three types of melanin actually. We have the eumelanin that gives color black and brown color, and we have few melanin that have few melanin is responsible for giving the red hair, freckles, and is responsible for the red and yellow color that we all have. Yeah. And when we speak about there's also the third type called the neuromelanin. And when we speak about neuromelanin, it's a melanin that is found in the brain. Though its functions remains very obscure, but because it doesn't have a dire or very valid, like a very rampant or dominant function on the skin, because it's found in the brain. So basically, the pheomelanin and the eumelanin are found in the human skin and hair, but eumelanin is the most abundant melanin in humans. Eumelanin is the most abundant melanin in humans, as well as form most likely to be what deficient in albinism. And so basically, when we speak about melanin, it has a lot of benefits to the skin. It provides a natural protection against the harmful effects of ultraviolet rays of the sun. And, and melanin is also a mechanism for absorbing heat from the sun. It also composes a lot of importance that sharpens to our vision because of because of what it comes about, and then is biosynthesis. Yeah. So as you said, if neither the gene If neither of your genes produces tyrosinase, definitely no melanin is going to be produced, as I explained earlier on, because the biosynthesis of tyrosinase basically what helps the melanocytes to produce melanin. So if that gene does not produce the tyrosinase, no melanin is produced, and definitely you're gonna have the congenital disorder called albinism. And moving forward, we have different types of albinism in the world today. We have the oculocutaneous albinism that mostly affect the eyes, skin, and that it mostly affects our eyes and the skin eye. Like basically the pores of the skin are very, very, very types that actually what severe and die. And then people with this type of albinism basically have white or pink hair and white or pink hair, skin, and iris color. So you see the picture on the slide. The girl has a very pink one iris color. The iris color is very dark. You see that there's a different shades of color in the iris, yes, because of what? Because of the type of albinism she has, and this as well gives her what vision problems. And there's the most severe type. There are actually different types of oculocutaneous albinism, where they have the different phases, the one, two, three, and four, and it's very dire as it goes higher. They have very severe and diverse symptoms, which can actually what cause them to have a whole lot of what vision problems and skin issues. And the second type we'll go into is called the ocular albinism. So you see, from the ocular albinism, it affects the eyes only. Skin color is usually normally what it's normally normal, or they just have a slighter lighter like skin color than their other family members. Even though it's very normal, you just see a bit variation of skin color or difference from their family members. And eye color may be in the normal range, but there's no pigment in the retina, basically. So eye color is the normal range and no pigment in the retina. It basically affects only the eyes, and they have three different types of phases of ocular albinism, and people usually you can see the picture on the slide, and see how different it is from oculocutaneous albinism. They have white, see that they have different shades of colors in their eyes, and then with the ocular albinism, they just have it only affect the eyes. So you see that all the parts and areas and colors of the eyes are being changed because they have no what pigment around their retina. But in the oculocutaneous albinism, there's a little bit of pigment, even though what their iris color changes. Yeah, it changes the iris color. But in the ocular albinism, there is no pigment at all in the eye. And we have different types of what phenotype variations when we actually speak about albinism. So you can see from the slide there are different phenotypes. See people that comes out physical appearances, see the hair, white hair because of the type of albinism she has. The little girls, they have different expressions of albinism. They are all different types that are available. These are the different phenotypic variations you can find in people with what? In people who are albinos. Now, we'll talk about the genetics of albinism. Basically, comes from the most types that are inherited are the also autosomal recessive, but some types are also X-linked recessive as well. And with autosomal recessive, most types of albinism are they're inherited when an individual receives the albinism gene from both parents. And if parents are carriers, the child, if parents are carriers, the child has a 25% chance of being completely normal, a 50% chance of being a carrier, and a 25% chance of getting albinism. So when both parents are carriers, they are not what they are like they can receive them because both parents are carriers, so they are 25% chance of a normal and 25% chance of what of albinism, and a 50% chance of them what of the child being a carrier because both parents are carriers. Now looking at here, so basically both father and mother are carriers. So see both parents are carriers, so they are able what they can so see that 50% of the children can get what can be carriers, 25% affected female, or 25% unaffected child. So either 25% affected child, 25% unaffected, and 50% carrier. So that's basically what we term when someone has a one and what gets the albinism when it's autosomal recessive, because we can see the colors. The blue stands for the normal gene, and then the orange color basically stands for an abnormal gene. Now when we speak about the X-linked recessive, That's the other type of what albinism, which mostly it's very rare, but it can what it can also affect. Now, basically, the you see that the parent is what it's a form of albinism primarily affecting the eyes. They will talk about the X-link. So it has basically comes with visual impairments common to all forms of albinism because it is what is X-link and it affects mostly what boys. So basically, you can see that the father is a dominant allele with no what has no carrier. It's not a carrier. It's not a carrier, and it's a dominant allele. And then basically the wife or the basically the mom, it's having what is a dominant carrier. It has a carrier of the gene. So basically, when we speak about the X-linked recessive phenotype, we see that the male is affected because if the mom is a carrier and the father is no carrier or is not or is unaffected. So you see that when they give birth to children, basically the likelihood that what a male child is gonna get albinism is very high because he's only going to receive one X from the mother and the Y gene from the father. So the X gene received from the mother, if it's unaffected, what allele, then what the male child is going to get affected. So basically, you can see that there is equal percentage. So there is only like about 50% chance of the male child getting affected, and there's 50% chance of the male child not getting affected, and there's only 25%. There's like zero chance of the female child getting affected or being albinic. She'll only be a carrier. So there's 50% chance of the female being a carrier and 50% chance of the female being unaffected at all. So basically, that is it. That's why it mostly affects boys. Boys are they can get what albinism as a result of what a dominant as a result of only one X gene, which is the affected gene from the mother. So going forward, there are actually many causes or the epidemiology that causes a lot of this albinism. And albinism is basically caused by what the, as we spoke about earlier on in the genetic stage. It's caused by mutation or an alteration of the gene that makes the melanin pigment. So the absence of the melanocytes and everything is going to cause albinism. And albinism is actually it's inherited genetically, as previously stated. It is autosomal recessive, and some types are what are X-linked recessive. So basically, those are the types that actually happens and they are involved. So and moving forward with prevalence and incidence, there are a lot of albinism people that have albinism in the world of different races, different types. We have Asian albinos, we have African albinos, we have the European albinos. There are a lot. So the international average for albinism is about 1 in 20,000. So in the US, one person in 17,000 has some type of albinism. So research indicates that the first type, that is the oculocutaneous albinism, happened by 1 per 4,000 of the population. And while the second, the ocular albinism, happened by 1 per 15,000 of the population. Okay. Going out, and it happens all over the world. As I said before, it affects all vertebrates. It affects people from all races. It affects men, women of all ages. Albinism is observed in many animals too, as I mentioned earlier on. It is no respecter of persons or organism. It's no respecter of sex or gender. It happens in everyone, everywhere, every country, every continent. Anyone can be affected, and anyone can be what an albino or can have what an albino gene. So moving forward, these are examples of albinos of different races. All over the world, people that are affected by albinos, you can see a slide from people in Africa, an albino from Africa, an albino from the Western continent, the European. You can see an albino from also what from different races, what Australia, right? And as I said, also albinism in different animal species. So you have the tiger, we have the turtle, we have the lion, the expression of different genes, no respect of persons or organism. It affects everyone, every species the same way. See, an example in birds also. So I try to bring different varieties of organisms to see what the different expressions of albinism. You can see the eye of the bird. You can see definitely that what is an albinism. The bird is affected. And when we speak about the symptoms of albinism, actually, it's basically a reduce or absence of pigmentation, a coloration of brain, skin, hair, retina, the iris, and it causes varying degrees of problems. So I mentioned them. We have vision loss. There's light sensitivity. That's photophobia. You have a problem with that. Then you have this issue with like rapid eye movement because it causes variation of symptoms. You see that you have rapid eye movements. You have crossed eyes, stems as the term known as strabismus. You have abnormal vision, nerve routing, and sometimes you see that you have sunburns. Your skin is easily sensitive to the sun, causing you to have irritations, some rashes, and reactions. So these are basically the symptoms that an albinic person experiences. These are really uncomfortable for them and can lead them to actually what having different what life complications. And speaking about visual abnormalities, all types of albinism show what show various different types of variability in their expressions. They're actually different types. So we have what we call the iris trans illumination, basically where you can see that the iris kind of like starts having different pigmentations and coloring that happens as a result of a person having what being what albinic or having the albinic gene. So and there's also you see that there's a hypopigmentation of the retinal pigment epithelium as seen in the slide I showed of a person having the oculocutaneous what um oculocutaneous albinism. See that there's a hypopigmentation in the eye. All albinic types actually have this, and you see that there's a fovea, but it's very diverse, like very absent in someone that has what an ocular. Okay, that one they have no pigment at all. Yeah. And you see that we have foveal hypoplasia or dysplasia, a very clear, distinct dysfunction of someone who has an ocular albinism. So there's an optic nerve head morphology. Yeah, basically people actually have their optic nerve is basically what kind of like pressed or compressed or released. So they basically have vision issues. Their optic nerve kind of like uh different like let's say diminishes and they have an issue with that. So and the variability actually depends on the genotype and then the ethnical background. So people from different races and from across different continents have different variations, and because of where they are from and their genotype, they express or they show different signs and abnormalities and symptoms all over the world. Now going forward, see there's a normal person with the eye, the fovea, I decided to show somewhere around the eyeball, the fovea and everything you see, and normal, and the person that is an albino. So you can see the differences of the way you can see the differences as I was talking about. So their neuro retinal rim, the cup edges. So the cup edges are basically supposed to be in shape and order, and not crisscrossing each other and not moving from their original position. But basically, looking at the albino, you see that what they they dissociate from the original or their original place position because of what because of hypopigmentation and because of what of displacement. So they displace their positions and what they form what a very what grave entanglement here that causes the person to have what a very grave what very grave vision issues and cannot actually see. So basically, when we continue, you can see an albinism. That's someone that has oculoacutaneous albinism. So when the tyrosine is basically not able to be what to be produced. So you see, so there's a normal melanocyte, and then what a mutated melanocyte. So these are the tyrosine. So the tyrosine is supposed to what to produce the melanin pigment, but when the tyrosinase enzyme that is supposed to produce the tyrosine is absent. You get it? So the enzyme is absent, so the tyrosine cannot be converted into dopaquinone to be able to get the melanin pigment. That's supposed to be what? Supposed to be a normal formation of um, melanin in your melanocyte. So when it's mutated, there's no tyrosine. So the defective tyrosine prevents the melanin what formation. So your iris, your retina will lack the pigmentation what to the pigmentation. So there's going to be potential oxidative what damage, which causes to have what a defective melanocyte. So your melanocytes will be what will be mutated. You cannot produce the no tyrosinase is available to be able to convert the tyrosine to melanin. So therefore, you're gonna have what absence of melanin, and therefore albinism will start to appear. And in this case, you see that you have your iris starts having what your pigmentation of your iris, your retinal removal of the reactive oxygen species to protect the cell from oxidative damage, because your iris and your retina will need the pigmentation to be able to react to help protect to protect your cell, the cells of your eye from what from pigmentation from oxidative damage. Sorry, from oxidative damage. So when the pigmentation is not available, you have what you start having reactions because there's mutations, there's defections. You know what? There are actually other issues that so you can see the slide. People, as I said, people from different races, an Asian albino, you can see an Asian albino and an African albino. You can see the Western part albino, and basically what I showed a slide of a girl Alexis before surgery and after surgery. They try to correct. They try to maybe to correct her vision, and then it's no there's no really a dye like a very like profound treatment for that, but at least it can be curbed and it can be checked here. So, and also speaking about other abnormalities, we have the brain abnormalities in albinism. The melanin, dopamine, tyrosinase, and tyrosine are involved in embryonal, fetal, and postnatal neural differentiation in mammalian and individuals. So basically, in the neurological abnormalities, you can see aberration of the retinoneural topography. You can see an optic nerve. The optic nerve hypoplasia is frequent and mostly seen. You can see atypical uh, chiasma crossing of the optic nerve fibers, and you can see atypical architecture of primary and what and associative what visual cortex. So all these what fibers and nerves in the eye, and then the visual and the architecture of the visual part is always what is diminished, and there's always problems with you having a greater amount of vision, and it can affect your brain and then your normal neurological functions as well. And moving forward with the prognosis, they can be when because basically when visions are invariably like severely impaired, albinism does not affect the expected lifespan of a human being. Yeah, but people with albinism may be limited in their activities because they can't tolerate the sun. So an activity that maybe a normal person will be able to do under the sun, an albino will be restricted. They will be limited. They actually curb their life to be able to live longer. It doesn't cut their expected lifespan. They just have limited activities, and when they and go into complications, that's when it can affect their life. And basically you can see talking about a patient. I try to get a patient, and then you can see I try to get a patient. So you see this is a normal on the right you see a normal patient, and on the left you see an albino patient. So basically you can see the difference in their hair color. You can see a difference in their eyes. Then you can see you can see different in the eyes, and then instrumentally or diagnostically you can see a difference in the eyeball. See the iris and the sclera, you can see clear differences. And you can see when I was speaking about what their retina, and then they on the sclera having problems. See that a normal person has a very correct their fovea is very lined and everything, but in a patient they have a dye issue. So you see that it comes up and it bulges. So that's the difference between the slide between a normal patient and then an albino patient. And with the complications, they lack skin pigmentation, making it more susceptible to sunburn and skin cancer. So they can literally develop cancer. That's when they expose themselves to the sun often and more. Because that they can have skin cancer where they have to undergo surgery, and it can lead to a whole lot of life complicated issues. And some of them can also lead to blindness. because of what? Because of exposure to a lot of things they're supposed to expose themselves to. A lot of light, a lot of rays can affect their eyes, and they can be blind as well. And then their albinism may also cause social problems because people with albinism look different from their families, so they can be have a lot of social maybe discriminations from their from their peers and other members of their ethnic groups. People will discriminate against them, will laugh at them, will mock them. But people with albinism mostly experience what we call bullying, teasing. They basically experience bullying, teasing, and probing questions about their appearance, their eyewear, what makes them have this complication and all that, and they actually experience a whole lot of issues and because of what these factors. It's not their fault. They are albinic anyway. And basically, when we speak when we continue, you can see that with the biochemical basis, you can actually what the biosynthetic pathways. So the first step that happens, how a person actually develops what actually gets to an albanic stage. So that I mentioned, so the step as I mentioned before, from the tyrosine into converted to dopa to dopaquinone. So the combination, and these are all biochemical synthesis of how what how the person develops in the gene to what to getting what to getting formation of melanin. That's eomelanin and few melanin. And this is an example of the biochemical structure biosynthesis of a normal person to get what to get a few melanin, eomelanin, or what a black form of melanin, any type of melanin that actually what that processes in the what in the human body. And so this is the part whereby it's not produced as I mentioned earlier on, and then what? So no melanin is produced, and what albinism comes in this stage where the tyrosine to dopa and then no tyrosine is, and therefore what albinism appears. And then so the result of no melanin is an albino. Basically, with a slide, you can see an albino differently from a normal person, and then the two birds, an albinic bird, and then a normal bird. And with a diagnosis, albinism can first appear at birth because it is a physical deformity that never changes. So you can detect it at birth because of irregular pigmentation is easily to detect it. And then the curbing and lifestyle can be what can be done from there. So diagnosis is based on a careful history of pigment development and what an examination of the skin, hair, and eyes. So the most accurate way to determine albinism is what is a genetic test. For example, chorionic villus sampling test and mucin tests can identify albinism during the second trimester of pregnancy. And also hair from the scalp can be used to assess tyrosine's activity by determination of the dopa and melanin concentration. So dopa and melanin assessed by radioactive biochemical assay in which the samples are incubated with a radio-labeled tyrosine precursor and what the amount of radio-label released after what enzymatic conversions and quantified what spectral photometrically. So the value of this test is debatable since a negative result indicates like the occulocutaneous type 1, but a positive result still leaves the possibility of what any type of what the type 1 or the type 2 what albinism. And the management and treatment, there's actually no cure, as I mentioned earlier on, for albinism because it's a genetic disorder, but treatment is limited. It can be treated, but the only thing is that we can only reduce the symptoms. But the skin and the eyes must be protected from the sun always to keep the person to have what a long lifespan from getting complications of cancer and blindness and other things. So the skin can be protected by using sunscreen creams, as a slide as a picture there, and we can always wear special UV protected clothing to reduce what sunburn risk. So children should also receive annual skin assessment to screen for skin cancer since what they are they are they are going to be what likely to be exposed to cancer because of lack of pigment in their skin. And also your eyes, you can also wear protection, glass protection, and all that, and the lenses, which can provide improvement in their vision. So wear dark sunglasses, which are UV protected, to may relieve the photophobia, and then the eye muscle surgery to sometimes recommended to correct abnormal eye movement. That's why I spoke about the symptoms and nystagmus. And for strabismus, ophthalmologists to prefer they always prefer to treat infants starting at about 6 months of what of their age before the function of their eyes has what fully developed. So it really helps them so that they don't become blind, they don't have excess complications in their what in the later stages of their life. And children should receive annual examinations by what by ophthalmologists to be able to help them to have a long lifespan. Basically, thank you very much, and I really appreciate. I'm done. Thank you. My name is Elijah Gamson from Fifth Course in Group 15. Thank you.